class, welcome back to another exciting pre-calculus video. I hope you're all as excited for this as I am. Today we're really going to do a couple things. We're going to review the difference quotient, which you can see right now, and then we're going to get into domains of functions. Okay, so difference quotient review. First things first, we need to remember what the formula was. If you remember correctly, towards the end of my last video, if you watched all the way through, I said it looks a lot like calculating the slope or average rate of change. The only difference is like, well, the x's are going to cancel in the denominator. We're going to end up just having the h value. So again, this is the difference quotient. And if you remember correctly, there's two functions that go in the numerator. One of them is this goofy looking x plus h, right? F of x plus h, which just means I'm plugging in x plus h and I get out f of x plus h. And then I have to subtract just f of x. Okay? So if you remember, we ask you to do this in two steps. First step, everything to do with f of x plus h. Get this first. This is probably the toughest part and the part where most of the mistakes would occur. So let's check it out. I know that I need to input what into the x spot? Well, I need to input our input, x plus h. Okay, so once we do that, we really just need to start cleaning this up. Okay, x plus h squared, we could rewrite that if that helps. And we know that when we have something like this, when we have two quantities multiplied by each other, we're going to FOIL. So we have what? X squared, and then we have an x times h, but then another hx when we do. So we have outside is x times h, and inside is x times h. So we really have 2xh. And then lastly, h squared. And then of course the minus 9 has to stick around. So we're almost done. Last thing, we finish up by saying f of x plus h, sorry, that's an h, equals 4x squared plus 8xh plus 4h squared minus 9. Whew, okay. Alright, so again, that is where most of the errors will occur. This wasn't too bad of a function. They get tougher. Alright, when you get into calculus, there might be some real crazy stuff. Now that we have that, we're ready for step 2. We're ready to calculate the difference quotient. Alright, well, we know that we're going to have everything over h. We know also what f of x plus h is. So I'm literally just going to copy down what I just did, or what I just found, I should say. And then notice the last thing that we're missing right now, we're missing this minus f of x. Okay? So what I'm going to do, I'm going to say minus f of x, right? I need this. Well, I know f of x is right here, okay? So what I am going to do is I am going to subtract this function, which means I need to subtract every piece. So I'm going to subtract 4x squared, and I am going to subtract negative 9. Well, subtract negative 9 means I'm actually adding 9. Okay? So now, what is supposed to happen? We're supposed to be able to cancel stuff out. If you don't have that happening, then you're doing something wrong. You got to try again. Alright, because we keep going, we now see, sorry, that should be equal sign, 8xh plus 4h squared all over h. Well, we can factor out an h, so we have 8x plus 4h all over h. And then again, we cancel out these h's, and we know that our difference quotient is, oh, sorry, I'm off the page, 8x plus 4h. And you are done. Alright, so there is a review of the difference quotient. What we're going to move into now is domains, okay, domains of functions. Domains of functions are not too bad, okay? It's a lot of the times it's not even really like solving the problem. It's more understanding where there's some restrictions on our graph or on the function. So what I want you guys to remember, and hopefully you do, domain has everything to do with x values. And more importantly, I care about the possible x values, and I guess I could just say x values that are possible. Okay? So when we look for the domains, or when we're trying to find the domain, we're trying to find the x values that are possible. Now, we know some things. For example, if you have an expression underneath a radical, well, what's true? Hopefully you guys remember from Algebra 2, can you take the square root of a negative value? No. I mean, if I show you on the calculator here, let's make sure I'm here, okay? When I try to take the square root of -1, error. Okay, what happens when I try to take the square root of 0? Okay, now I'm good. And then anywhere forward, I'm good. Okay, so what we say here, for the domain, and really what we say, we cannot have a negative. No negatives allowed. Which means, when we find the domain, we're going to do the expression must be greater than or equal to 0. Okay? Well, what happens when we move on to something like this, when we have a denominator or an expression in the denominator? Well, again, hopefully you guys remember that, well, if I take 1 and I divide by 0, it doesn't work. Okay? So what we say here is our expression cannot be 0. So that's written something like this. Okay? Lastly, radicals in the denominators is really just a combination of both. We know that it's an expression under a radical, so it can't be negative. We also know that it's in the denominator, so it cannot be 0. So we say the expression must be positive, right? If I'm writing expression must be positive, what's another way to say that using inequality symbols? Yep, absolutely. You said it right. The expression must be greater than 0. Now, there is some solving. Once you have all of these set up, you are going to go ahead and solve to help you get the domain. So let's look into this now. Something like letter A. F of x equals x squared plus 5x. All right. Is there anything under a radical? Is there anything in a denominator or a combination? No, there isn't. So really, guys, I can plug in absolutely any number, right? I could plug in -1, I could plug in 3, I could plug in -1 million if I wanted to. There is no restriction on the domain. So what we would say here is that the domain, that's a D, sorry, is all reals. Or what I'll tend to do, we call this, if you want to call it a double bar R, that's really just a notation for all real numbers, the set of all real numbers. Okay? So this would be our answer for that one. All right? When we move on to B, well, now we see something, right? What do we have? We have something in the denominator, so we take that expression in the denominator, x squared minus 4, and we set it not equal to 0. Okay? When I factor this, this really turns into the zero product property again. It's just that it's not going to be x equals 2 and x equals -2. It's going to be x cannot equal plus or minus 2. All right, so now we know the restrictions on x. X cannot be positive 2 or -2. That would make this not work. To finish this, what we do is we say that the domain is all real numbers except, or a comma, x cannot equal plus or minus 2. Okay? All right. Let's check out the next one, letter C. Letter C, we see an expression under a radical, so we know we're kind of like up here in this first box. So we take the expression and we say that it has to be greater than or equal to 0. All right, we solve this. So we subtract 4, We have negative 3x is greater than or equal to negative 4. We divide by negative 3. This is when you have to be careful. Does anyone remember from a long time ago, past algebra classes, when you have inequalities and you divide by a negative, please, please, please remember that the sign has to switch. All right? So now we have our restriction on x. X has to be less than or equal to 4/3. That means it can't be 2 or 3 or 4 or 5. It has to be less than this. So what we're really going to do here, guys, is we're just going to say the domain is x is less than or equal to 4/3. Now, we will go a little farther into this when we get into interval notation, but for right now, this is what I'm looking for. Okay? All right, we're just going to keep practicing these, and there's a lot. So let's go, I don't want to say quickly, but let's get through this, and hopefully you guys will be able to understand all of these and really feel comfortable with these by the end of the video. All right, so now I have a radical in the denominator, which means I am which situation, which box up at the top here? First, second, or third? Third, very good. All right, so when I come back down here, I now know that my expression, x plus 4, must be greater than 0. Okay, it cannot be negative, it can't be 0, so we set the expression greater than 0, and we solve. X must be greater than negative 4. Add the domain. Done. Easy. Easy. Very, very nice. All right, when we move on to letter E, do we see any radicals? Do we see any denominators? No. That's an immediate sign that your domain is all real numbers. And again, guys, you hopefully should know this. X squared minus 9, that's a quadratic. That's a parabola, right? If you graph a parabola, doesn't it go on forever in both x directions, both in negative x and positive x? So this should make sense. All right, how about F? We have a denominator. X cannot equal 0. Oh, this one's nice and easy, right? So really, we just need to add domain is all real numbers except x cannot equal 0. Again, I know I kind of sped through that. That was just because, look, my expression really was just x. So it was as simple as that. It was just take the expression, set it not equal to 0, and you're done. All right. G. We have a denominator. So we know that we're in that middle box. We know we have to say x squared plus 5 cannot equal 0. This is when it doesn't really factor nicely, so I'm going to use the square root method. I'm going to say x squared cannot equal negative 5. And when I square root both sides, I end up getting, can I take the square root of a negative? No, so here, I really don't have a solution. Okay? Well, if I don't have a solution for a restriction, then what do you think I'm going to say? Well, then there's no restriction. Then the domain is simply all real numbers. And hopefully that makes sense, guys. I mean, this is, again, I know it kind of is, it should be a little similar to letter E, right? If we have a parabola, or sorry, not a parabola, a quadratic, you know that you can plug in any x value. And in this case, because it's x squared plus 5, anything I plug in for x, whether it's negative 1 million or negative 1, or even if it's positive values like 3 or 100, this is always going to be a positive. Positive plus 5 will always be positive. It will never equal 0. So it is okay. This will always be okay. All right. If I didn't explain that very well right there, let's talk about it in class. Moving right along, we have an expression under a radical, so we say that that expression has to be greater than or equal to 0. Oh wait, sorry, I did not need the all real numbers there. Just x is greater than or equal to 16. My bad, guys, sorry about that. All right, last one on the front, or on this page, sorry, second page. I know that I have a denominator, so x squared minus 16 does not equal 0, sorry. This one, very similar to letter B. If you want, you can factor. I'll use the method that I know you guys like. I know you like the square root method. The only thing you have to be careful of is what? When you take the square root of 16, it's plus minus. Now I'm going to say that the domain is all real numbers except for x cannot be plus or minus 4. All right. Next, last page. At any point, guys, at this point in time, I would say if you're starting to feel comfortable with this, you don't necessarily have to take all of these notes. However, if you're not feeling super confident in this, please stick with me until the end. All right. Let's see here. Let's go to red. All right. So we have a radical, which means we're in the first box situation. So I take my expression, 9 minus x, and I say that it has to be greater than or equal to 0. Well, I can just move this over. And that should, wait a minute. Yeah, that's right, my bad. Very good. Now we know, and I'm going to just write it the other way though, sorry. X is less than or equal to 9. So the domain is, I did it again. The domain is x is less than or equal to 9. Okay, that should make sense, right? If we take an 8, right? 8 is less than 9, we can plug that in, that's fine. But if we took something greater than 9, such as 10, well, 9 minus 10 is negative, and then we can't do it anymore. Okay? Sorry about that. We move on. We see nothing going on here. No radicals, no denominators. This is fine. We can plug in absolutely anything. There are no restrictions. We have a denominator in the next one. So we know that that expression in the denominator cannot equal 0. So x cannot be 14. And then we just say the domain is all real numbers except for x cannot be 14. When we take a look at something like m, okay, this is slightly more difficult but definitely doable. We see we have something in the denominator, which means we have to say that 2x squared plus 7x minus 15 cannot be 0. Well, this one we'd have to factor. We have options here. Personally, I would stick with what I've been doing with splitting the middle, right? I would multiply a and c, so I know I have negative 30, and I need to say, well, what two factors of negative 30 add to 7? That is a 10 and negative 3. That is a 10, sorry, 10 and negative 3. So, 2x squared plus 10x minus 3x minus 15. I can factor out a 2x from the first two terms, which leaves me with x plus 5. And I can factor out a 3, which leaves me with x plus 5. So I know that I have 2x minus 3, x plus 5. And again, my bad, I should have been writing this, cannot equal 0. So now I use the zero product property, basically. I say 2x minus 3 cannot equal 0, and x plus 5 cannot equal 0. So let's see, I move the 3 over. What do we get there? X cannot be 3 halves, and x cannot be negative 5. So I finish this by saying the domain is all real numbers except x cannot equal 3 halves and negative 5. All right? All right. Let's keep going. We have a radical. 23 minus x then has to be greater than or equal to 0. Let's see here, I move the x over, so 23 is greater than or equal to x. I just kind of turn it so I make a little more sense out of this. And we are done. All right, now on letter O, I don't want you to freak out on this one, all right? Nothing really changes. Absolute value does not change the domain. All right? So really, are there radicals? No. Are there denominators? No. So really, guys, this one is very similar to something like k. All right? This is just a quadratic inside of absolute value bars. We're fine. There's no restriction. You can plug in absolutely anything, so domain is all real numbers. All right, we're almost there. We are almost there. Letter P. Letter P. What do we have here? We have something in the denominator, so we know that this expression cannot equal 0. Ooh, what's going on here? What is this called? Difference of cubes. Very good, I like it. So we have x minus 2. Why? Because the cube root of x cubed is x, the cube root of 8 is 2, and now we just follow the pattern. Same, opposite sign, then we multiply, so ab 2x, always positive, 2 squared is 4. Alright? Now if you remember correctly, I told you guys this is always going to be complex solutions, so we do not need to worry about this right now. Okay? What I need you to do is just understand that this is the piece where I can actually solve. So now I know that my domain is x cannot equal 2. Q, nice and easy. Is there a radical? No. Is there a denominator? No. Alright, this is fine. We can do this, no problem. You can plug in absolutely any value and you will be okay. Okay. Alright, last one. Finish strong here. We have a radical in the denominator, which means that that expression not only has to be positive, but it also cannot equal 0. So, x minus 16 has to actually be greater than 0, which means that x must be greater than 16. We finish by saying that is our domain. Okay, so we just did a ton of practice on these. Hopefully you guys are feeling fairly confident on these at this point in time. Of course, we will continue to practice. If you have any questions, please make sure to always ask me or neighbors or friends, whatever. Do what you have to do to succeed. Yeah, I hope that this video helped you guys out, and I will see you later.